Hi, I'm Dave Goldberg with the Computer Science Laboratory at the Xerox Palo Alto Research Center, and I'm here to tell you about some thinking we've been doing about pen-based computers, so computers that use a pen instead of a keyboard. And in particular, we're interested in the problem of how you get text into such a computer if you don't have a keyboard. Now, the more I work with pen-based computers, or styluses, the more impressed I am about the invention of the keyboard. And one of the great things about the keyboard is it works well for beginners and experts. A beginner can enter text just by picking out one letter after another, and it's slow, but it works. With practice, you actually get pretty fast at it. And if you want to go even faster still, you can learn touch typing. It takes a little while to learn touch typing, but touch typing is really fast. And not only is it faster, but you have eyes-free operation. You don't have to look at your hands while you're typing. Well, let's see what happens with a stylus and how people write with a stylus. I have here an NCR 3125, a pen-based computer, and it's running PenPoint. And the way this system works is that you get a grid of boxes. You write one letter per box, print your message. And then when you're done printing, you hit the OK button. It tries to recognize your writing. If there's any errors, you just write over it correct. Try to get that I there. Change that to an M. And then when you're happy with your message, you hit the OK button and it's inserted into your text. Now this is fine if you're just entering a little bit of text, but it gets pretty tedious if you're entering a whole memo. So imagine you're at a dull meeting and all you have is your pen-based computer. You want to make use of the time by writing some documents. This is going to be pretty tedious and you're going to wish you knew something like touch typing. So that's what we've been thinking about, is what's a system that you can learn that will make text entry with a stylus easier? Now, you'd like the system to be better than printing, and what does better mean? It means faster, of course, but there's more than that. You want it to be more flexible. Pen computers come in all sizes. Here we have a little experimental pen computer with a tiny screen. You'd like the system to work very well on a small screen. And you'd also like to be more accurate than ordinary printing. The problem with ordinary printing is that it's a very ambiguous process. Let me show you an example. Let's take the letters R and V. And R looks like that, and a V like that. They're different if written carefully, but in real life, people tend to do that. You can't really tell if that's an R or a V. And there's many examples of letters which blur together like that. So we'd like a system which is more accurate, as well as being faster and more flexible. So what I'd like to do next is tell you about our idea of a system that plays the same role as touch typing for keyboards does, but this is for pens instead. Well, our idea is to use a special constrained version of the alphabet, which is easy to learn, takes about 10 minutes to learn, but works much better with a stylus than the ordinary alphabet. And here's our alphabet. There's 5 different shapes, and each of them come in 4 different orientations. And unlike the ordinary alphabet, each shape is quite different from the next, so as you write more quickly, you don't get the shapes confused. They don't blur into one another. Well, let me show you how easy this is to learn. Many letters are the same. For example, a V is just a V, an S is just an S, and other letters are kind of the obvious subset. So, for example, an F, that consists of 2 parts, and in our alphabet, we just take the 1/2 of the F, kind of a natural subset. Other letters are the same. For example, a T, normally that's 2 parts. We just take the crossbar of the T. So again, it's just a easy-to-remember subset. Now, you notice that each of these letters is a single stroke, so we call our alphabet Unistrokes. And the reason why this is useful is because when you're writing on a teeny little tab, it's very convenient to write one letter on top of the next. Not only does this save space, but you don't have to look at your hand. It's like touch typing, that it's eyes-free, so you can be taking notes or maintaining eye contact while you write with your pen. The reason why this ties in with single strokes is that with the ordinary alphabet, many letters are multiple strokes. For example, capital T, capital H, there's 5 strokes altogether, even though there's only 2 letters. And so if you wrote one on top of the next, the computer is going to see 5 separate strokes and has to figure out, oh, the first 2, those group together do a T, and the next 3, that groups together do an H, and that's, you can try to figure that out, but that's going to be a cause for errors, make the system less accurate. With our alphabet, every letter is a single stroke. It's completely unambiguous where one letter starts and the other letter ends, because each letter is a single pen up, pen down. Well, another advantage of our system is that it's much less ambiguous than ordinary writing. What do we do about things like U and V? That's a pair which is easily confused in ordinary writing. And what we do in our system is we use stroke order to distinguish those. So a U in our alphabet, what we do is it's the same shape. It's easy to remember. It's an ordinary U shape. But whereas a V, you write that in the ordinary direction, a U, you write that in the opposite direction. So it's easy to remember. The shapes are the same as the ordinary shapes. But to the stylus, to the computer reading the stylus, they look completely different because the pen is traveling in a different order. And so that solves the ambiguity problem in a way that's easy to remember. A final advantage of Unistrokes is that they're faster to write than ordinary letters because the common letters are all straight lines. So there's a T in the ordinary Roman alphabet is 2 strokes, and ours it's just a single straight line. And we've mapped all the common letters to straight lines, which makes it easier to write quickly. Well, enough of this theory. Now let me show you the system in action. Here's the program we use for testing our system. It's a mail sending program. Users send real mail messages using this. There's no modes. You just write letters in this writing area, and they appear on the top. To enter a subject line, I tap on the word subject, and I can enter my subject line. And then for a message, I tap on message. Now, you'll notice by default every letter is lowercase. To make an uppercase letter, I hold down this side button, so I can erase the lowercase I, press the side button, makes an uppercase I, and I can insert at any point. So if I draw a caret at the end, that moves the insertion point. And now if I want to, say, put an exclamation point at the end, for those rare letters that you can't remember the symbol for, we've got little reminders here with buttons. So I tap on the exclamation point button, and it inserts an exclamation point at the end of the sentence. A stylus is useful because it scales from the very small, like this teeny tab, to the very large, like this live board. Now, the problem with a live board is that although it has a keyboard, the keyboard's way over there, and if I'm standing over here, it's not very convenient to use the keyboard, and that's where stylus comes in. I'm always holding the stylus in my hand, and so it's much easier to enter text with the stylus than to walk over to the keyboard. Well, to summarize, the problem with the stylus is that entering text is not as easy as it is with the keyboard. So although stylus is good because it scales, it's not so good when it comes to text. And that suggests that if a stylus is going to be a truly useful input device, we need to discover some analog of touch typing, a system that can be learned, but once you learn it, entering text is a whiz. And although we don't know what that system is, it seems that Unistrokes may be the solution to the problem of finding a good analog of touch typing for a stylus.